1.2 linear equations in one variable. So you should pause the video and try to write down the answer or the vocab for these questions, for these words. And when you write down this vocab, it should be in your own words. It does not have to be exactly what if you look it up on the dictionary, because that will not help you as much as in your own words. So here we go. These are in my own words. Expression is basically when you think of equation, but there's no equal sign. Equation has an equal sign. When you're solving, that's the process that you're doing to get the x by itself. Solution is the actual answer that you're talking about. Identity. Identity is often a time when we have an answer and it's for all real numbers can work for that. These are the two ways. This way we draw two lines and then we start at the first line and we go to the second. That's the symbol for all real numbers, or else you can write all real numbers. Conditional statement is the typical one that we see when we get x completely by itself or any unknown by itself. And a contradiction is when we're solving, but everything is false, and that typically is going to be a no solution. Now, all of these are pretty straightforward. I'm going to pause the video, and I want you to do all four of these and solve for x. So for all these problems, you should always be thinking, what do I have? What's the opposite? So here I have subtraction, the opposite is adding, and then here I have multiplying, the opposite is dividing. Same thing, I'm moving over the x's. I typically move over the smaller ones. The opposite of a positive 3x is subtracting that 3x. The opposite of a positive 4 is subtracting that 4. Noticing that both of these are negatives, so that becomes a larger negative number. Here's a big mistake that people often do. They subtract the 7, but they forget to leave the subtraction. Subtraction is like a negative number, so we keep that negative with that 2. Divide by 2. Negative 2, we get negative 4. And here we get 8. Same thing here, it's just a little bit more to the solving process. So I want you to pause the video and try to do both of these by yourself right now. So here I distributed first. I personally like to combine like terms on one side. So these are on the same side of that equation, so we do the same sign. So negative 6 plus 4. We only do the opposite sign as if we are going to the opposite side. So this 3 was moving over, so I did the opposite sign. This 6 was moving over, I did the opposite sign. You should have got negative 1/3. I would want your answer in fraction form. Distribute, combine like terms, same thing, same side, same sign. Get negative 4, move things over, you get x is equal to 26. Now here where people tend to get a little more scared, I would say. I'm going to do B because of their fractions, but it's still going to be the same thing, just like how we've done before. We want to get our x's all together. We want to get our numbers all together, just like how we've done before. So the first thing I'm going to do, this is less than 1, so I'm going to subtract 4/9 x on this side. So that means I'm going to move this fraction to the other side. So I'm going to subtract my 5/3 on this side. So if you're not good with fractions, you can always use your calculator. Now, this is how I use my calculator if I'm going to be using fractions. You can definitely use a fraction key. This is a negative 1/3, so I keep it as a division, minus 5 divided by 3. Because of properties of, or PEMDAS, it's going to do that division first. And then I go math, change that to a fraction. Actually, I didn't have to change that for a fraction. Negative 2 is not a fraction. It can be. Then I have negative 2. Same thing here. If I'm not good at fractions, I could go 1 minus 4 divided by 9. I can change that to a fraction. You get a positive 5/9 x. Now, the beautiful thing with math, and sometimes people get frustrated with math, is at this point you can do multiple different ways to get your answer. Now, I'm going to break it up even more, but as we go on in the semester, I'm not going to break it up as easy. I'm going to get rid of this division, because this is the same thing as writing this, like 5x over 9. These two are the same equations. I'm going to get rid of that division, so I'm going to multiply both sides by 9. So I'm going to multiply this side by 9 and this side by 9. I get negative 18 is equal to 5x, because these two would cancel each other out. So the opposite of multiplying would be dividing. So I'm going to divide both sides by 5. So my answer here would be negative 18/5. And again, I want you to leave your answer as fraction. So I want you to try to do this one first. Remember, this is just like 1/3 plus 3/4. So get this together as one option first. So if you combine this 1/3 plus 3/4, again, you need common denominators, which would be 12 to get 13x. I purposely wrote it like this. You can write it like this if you want. I only wrote it like this because sometimes people are easily, more visually able to see that, oh, I'm going to multiply by 12, and then I'm going to divide by 13. And here's a little bit harder. I'm going to do this one first. One thing now I have to do, I have to try to factor this, because before I can combine any fraction, up here is easier because it was just numbers. Before I can combine any fraction, I have to have common denominators. So if I factor this with numbers multiplied to get -4 and add together to get 0, it would be this. Now, one thing, depending on who your teacher was last year, there are multiple different ways to go about doing this problem. I personally am going to combine these two fractions first, okay? So in order to combine these two fractions, I'm only going to be working with this expression. And then you get common denominators. Well, this has an x plus 2 and this has an x plus 2. So I have to force this side to have an x minus 2. So I'm not even going to touch this side yet. Not yet. I'm going to multiply this side by x minus 2 on both top and bottom. And the reason I'm doing is that so I can force that to have a common denominator. So now I'm going to rewrite this. Another thing I'm going to do, because a lot of times with subtraction people forget, I'm going to make this a plus a negative. Now I can combine these two fractions. First, I'm going to distribute this right here. Okay. Again, I'm not doing anything with this side yet. On this side, I have 3x minus 6 because I'm distributing that 3. And then I also have this minus 6 over here. Okay, that's combining. And on bottom, I'll have this x plus 2 and x minus 2. So I can combine those two. I'm kind of writing big. So I have 1 over x minus 2 is equal to 3 minus 12. 3x minus 12, because I can combine those two like terms. I have x plus 2, x minus 2. Again, from here, there's two different ways you can go about doing this. Because I noticed that these are the same on bottom, I'm going to get rid of this division. In order to get rid of that division and kind of to save me some room, I'm going to multiply both sides by this x plus 2, x minus 2. So if I multiply this side by x plus 2, x minus 2, this is what I have. This stays together. So these two will actually cancel each other out. Pacha! So what I have, because I just multiplied this over, what I actually have now is my x plus 2 is equal to my 3x minus 12. And now I'm going to finish solving that. So I subtracted my x over, I added my 12, so I get 14 is equal to 2x, divided by 2, I get 7. You want to make sure that this is the domain, and it is, because there are no, we'll get more into that later on, but there is no restrictions on x equals 7. I want you to try to do this one. Now here I combined these two first. Personally, I would subtract this fraction over here first, because they already have common denominators. That's what my first step will do. But I want you to pause the video and try to do that one by yourself. Now you might have gotten that x is equal to 4. So I move this over, I do this, I multiply this over. If you got x equals 4, you were partially correct. There's two things in this problem. Once I get this number, just like how I got this number, I should plug it into the bottom of the equation. If I plug this into the bottom of the equation, I get 0. That doesn't work. I cannot get 0 on the bottom of the equation. That's undefined. When I plugged in 7 over here, when I plugged in 7 in all of these locations, I did not get 0, so that's why 7 worked. Now, you could either do that at the end, or some of you may have noticed at this point right here, if I were to have factored out of 3, I'd be left with this. And at that point, so these two things are equivalent. They're the same. At that point, I could have canceled these two out, and I'd be left with 3 is equal to 5. Well, 3 is not equal to 5. That's a contradiction, like we talked about. So that right there is not true. Example 5, finding intercepts. So I'm looking at my intercepts. When I'm finding my x-intercept, that means y is equal to 0. So I have to figure out what x is. When I'm finding y-intercept, we are figuring out when x is equal to 0. What is y? So I want you to pause the video and do these 4 problems. So you may want to pause the video to look at these 4 answers to check your work. X-intercept negative 1 4th 0, 0, y 0 1, x here is 2 0, 0 3, negative 2 3rd 0, 0 negative 2, 3 0, 0 5. Now depending on how good at that you are at PEMDAS. Depends on the difference that you may have solved the problems. And the last question. So you should pause the video and read it first. I'm not going to go through and read it. Things that you should make sure that you understand is this important information. This is important information. The first part says find the y-intercept. If I'm finding the y-intercept, that means I'm plugging 0 in for t, time here. That's our input, just like x. So when I plug 0 in for that, we actually don't need to plug that in. We know that y is going to be equal to 2.70. So we have to try to think of what does this data actually represent. Well, if t is 0, it tells us right here that the participants in millions was 2.7 million. So in year 2000, there's 2.7 million female participants. Part. And B says, in what year do you think there'll be 3.42? Well, this is an output. This is how much my y represents. If I take this value and plug it into my y value, and I need to solve for t. I need to figure out what my t is. So pause the video right now and solve that equation. And you should have gotten t is equal to 16. You subtract this over, and then you divide by the 0.045. Now t is 16. You would think maybe the answer would be 2016. However, I have parameters on this equation. Okay, the parameters are in between 10 years. So this does not fit in our data. If I were to ask you this question, I should see this answer, but then also see not in our data. Not in our data. And there you have it. Have a wonderful day.